So when we're electrolyzing molten compounds, we have only two type of ions, such as Na plus and Cl minus. So we have no competitors, like only Na plus and Cl minus ions. So in the anode, on the cathode, we know what other things are coming and we know how to write the equations and all. That's all fine. So electrolysis of molten compound is somewhat easier because we have only two types of ions, like Na plus and Cl minus, one cation and the one anion. But when we're electrolyzing aqueous solutions, so this we learned from the previous lesson. When we're electrolyzing aqueous solutions such as sodium chloride aqueous, example, I'm taking sodium chloride aqueous. So this makes Na plus aqueous and the Cl minus aqueous. But guys, I told you in sodium chloride aqueous solution, yes, sodium makes Na plus aqueous and the Cl minus aqueous, but we have H2O as well. So this H2O also kind of an electrolyte, but this H2O is a weak electrolyte. Sodium chloride aqueous is a strong electrolyte, guys. Why I'm saying that as a strong electrolyte, that split completely to Na plus and Cl minus. But H2O liquid also try to make ions, but that happen like incompletely. So therefore, H2O liquid will become ions, will make ions, but it like partially. It's like a reversible way. So therefore, I'm mentioning H2O liquid also make ions, but it's like a reversible reaction, like this way. So this scenario, we need to consider only electrolyzing aqueous solutions. But you can see now the difference. When now electrolyzing molten compounds, we have only two type of ions, Na plus and Cl minus. But here, when now electrolyzing aqueous solutions, we have four different ions. So among them, which ion will be reduced, which ion will be oxidized, we have a doubt whether like among cations, whether Na plus or H plus comes. We have no idea. Among Cl minus and OH minus, which ion comes? We have no idea because an ion and the cation, there are four different ions we have here. Okay, guys, the doubt is clear. The way I'm going to explain, is that clear, guys? The electrolysis of aqueous solutions, there are some additional stuff. That makes sense to you?
Yes, sir.
Yeah, okay, right. So today we are going to start how we are going to electrolyze this aqueous solution. Yes, we have a doubt here, four different ions we have, but the other side we have only two different ions. So just take these two examples into your book, as I mentioned on the share screen, and just mention here. Here we have two anions and two cations. But guys, there we have only one anion and the one cation. So that's why I need to have a kind of a theory to get an idea which anion and the which cation react when I'm electrolyzing aqueous solutions. So guys, can you take these two comparison into your book first of all? If you have already taken this one the last time, I don't remember where I finished last time, because last time we have something glitching and the connection issues and all. Did you copy this kind of thing the last time? No, right?
So we did copper nitrate.
Yeah, I mean like the introduction of the lesson I gave to you, but you guys complained me like the connection issues are there, like, so you couldn't hear much. So that's why I'm starting the lesson again. So it's better just take this into a book again. And I'm going to explain that particular part again because you wouldn't understand that particular lesson, no guys, last time. Okay, right. Just take this into a book. The previous lesson, what we learned, molten compounds. Right. So when we're electrolyzing aqueous solution, we have no idea which ion reacts. Okay, guys, everyone, did you copy this stuff into a book? So people who couldn't understand last time, please take
Still
this.
copying.
Yeah, people who couldn't understand last time, just take this into a note. Because this is how I started the lesson. So exactly that way last time. I'm going to explain this lesson again to you. So once you're done, just tell me you're done. In a electrolysis mixture, when you have any halide, suppose Cl minus, Br minus, I minus ion is present, those ions will be oxidized first. Remember that. If Cl minus ion present, Br minus ion present, I minus ion present, either ion is present, so those ions will be oxidized. Okay, guys? If those ions are not present, anything else present, not these ions, then we have a particular reaction. I gave you that reaction. Do you remember that reaction I gave to you? Not much. Right. So remember the first point. My dears, can you take the heading selection criteria of ions? Just take a heading selection criteria of ions. Just take a heading selection criteria of ions. Selection criteria of ions. Right. Under that, take another subheading, selection of anions. Selection of anions. Selection of anions.
Okay, sir.
Okay, right. After that, my dears, these 2 points you are going to take to your book. So what I'm going to highlight it here. There are 2 points I'm going to highlight. Please take this into a book. So can you see what I'm highlighting here?
Yes, sir.
Yeah, please take these 2 points into a book. Set it like I'm sorry, something happened. I think I make it like yellow color. Please take that into a book. So it says if the halides ion present, those halide ion would be oxidized first. If not so, OH minus ions oxidize next. So that's the thing they mention here. Take those arrow pointed 2 points into book. Okay. And the second point says, if no halide ions are present, then OH minus discharge at the anode, gains electron and forms oxygen gas. The reaction I mentioned here, please take this reaction into book as well. The red color equation, can you see? Please take that reaction into book. So these all stuff I have given to you. Yeah, we wrote that, but we have to revise this lesson again because some people says they couldn't understand. So people, can you see now little clearly? Now more clearly?
Yes, sir.
Yeah. So these 2 points, 2 sentences, just 2 sentences. Please take to your book.
Sir, on the anode, oxidation takes place, right?
Yeah, exactly. That's the theory. We know that, no? On the anode, always oxidation is taking place.
Sir, why are they gaining electrons then?
Yeah. No, that means you gains electron that. That's the thing. It doesn't say it's like they are gaining electrons. So here, like if you get confused with gain electrons here, just okay. So that it means what I want to mean here. It doesn't gain electrons, it loses electrons, but from the anode, you are gaining some electrons. That's the thing is point is mentioning. So if it confuses you, just cut the point, the gain electrons here. Just cut the point, the gain electron here, because it just makes something else, just complete that point. I'm really sorry, I couldn't see that. It makes you a little confused. So always remember anode oxidation is taking place. So whatever the halide present, those halide will be oxidized, losing electrons. Yeah. If halides are not present, OH minus ions will be oxidized. So there are two points I have asked you to write here, guys, but it's mentioned like gains electron. So I cut down these 2 points. So please take the note. Please take these points now correctly. And after second point, please take this equation to your book. So it says how OH minus ions oxidize and losing electrons. Okay, guys, is that clear for you?
Yes, sir.
Right. Okay. So we'll go to the after that, the negative electrode, the cathode thing. The heading we started the selection criteria of anions. Now we start another subheading under the the note, your note, what you're writing. The next subheading is selection criteria of cations. Take the next subheading into your book, selection criteria of cations. Selection criteria of cations. So guys, I'm going to discuss about the cathode now. To the cathode, yes, we have 2 types of ions, like the metal ion and the H plus. The above examples I gave you, Na plus and H plus. So here, which ion will be reduced? We have a doubt. Both ions will come to the cathode, but which ions we are going to select? Please remember that's we are taken from the reactivity series. Remember, guys, in the reactivity series here mentioned, everyone can see the reactivity series is mentioned here. Can you copy this reactivity series later? You copy this reactivity series later to your book, but look at the reactivity series. Can you see the hydrogen in the reactivity series, guys? In the diagram here mentioned? Yeah, you can see the hydrogen here.
Yes.
Yeah, any metal contain above hydrogen, guys. Any metal contain above hydrogen, such as these metal I mentioned here. If these metals contain in the electrolyte, the particular solution, those metal ions won't be produced. Remember that. In a electrolytic mixture, in a aqueous solution, which you are going to electrolyze, suppose it contains any metal ion above hydrogen, such as here Na plus, or calcium 2 plus, or magnesium 2 plus, whatever ion. So those ions won't be oxidized. Instead of that, H plus will be oxidized. Remember that. If any metal ion present above hydrogen, those metal ions won't oxidize. H plus will be oxidized. But any metal ion below hydrogen present, such as here copper, silver, gold, something like that, something like copper ion, something silver ion, something gold ion present, those ions will be reduced, not the hydrogen ions. Please remember that. So what I mentioned here, please remember again, any metal ion present. So this scenario comes when you are selecting the cation. So when you are selecting the cation, the metal ion is above hydrogen, such as here given in the series. Any ion present above hydrogen, those metal ions won't be reduced, except that H plus will be reduced to form hydrogen gas. But in the electrolytic mixture, the metal ion is something like below hydrogen, such as copper 2 plus, silver plus, and the gold plus, anything, something like that ions, those ions are present. Those metal ions will be reduced, not the H plus this time. So please remember that particular scenario. So you would say, so it's very difficult, no, sir, because there are many things we need to remember in the reactivity series. Above hydrogen, see, there are many metals. But guys, just remember, below hydrogen, you have only copper, silver, and gold. Any ion like copper or silver or gold or something present, those ion you consider, those will be reduced. So instead of any metal ion present, apart from those any metal ion present, so you consider them, those metal ions won't be reduced, H plus will be reduced. Okay, guys, did you get the point? Yeah, right. So
Yes.
everyone is, yeah,
sir.
everyone is, yeah, is that clear, right? Okay, we'll go to the writing part now. What are the points you need to copy into your book? Right. Please see, there are 2 points you are going to copy into your book. If the metal ion is above hydrogen in the reactivity series, then hydrogen will be produced and bubbles will be seen at the cathode. Okay. Please take that point into your book. And the second point you are going to take into your book, that and the third point as well. Please take these 3 points into your book. And the hydrogen, how it reduce, I'm going to write it. So you will copy that equation as well. So this is how hydrogen reducing, H plus reducing. So this H plus thingy comes when the metal ion is above hydrogen. So H plus won't be reduced when the metal ion is below hydrogen. So sorry, very simple. It's like a joke, guys. Very simple. Okay, right. Okay, buddies, did you copy?
The last part.
What is the question I you have? So here, what are the least reactive metals? I'm just going to mention here, such as copper, silver. Like with the charge, I'm going to write. So basically, these two ions. Just remember, if these two ions are present, these two metal ions will be reduced. Anything else, anything else metal present, those metal ions won't be reduced. Apart from that, H plus will be reduced. This is so easy. Right, hope you have taken the note into your book. Right, okay. So guys, everyone copied this into your book? Yeah, right?
Yes, sir.
Right, okay. We'll move to the next part here, the things you need to understand and you need to remember a little bit. Few observations, guys. Sometimes the ATP paper, this would be seen, but sometimes theory paper also I have seen like there's a trend like they're asking some practical scenarios, like not the practical thinking, but they would ask some observations. They would ask what's the color of the gas produced, what's the precipitate color. I have seen like specimen papers is the new syllabus, new update. So it's better to take this note into book. So it says if the gas is produced at the cathode and it burns with a pop, scoopy pop sound, something like that sound, so that gas will be hydrogen gas. Okay, you know that the hydrogen gas identification test. And when you have kind of a glowing sprint that become relights, the gas produced will be oxygen gas, because those are like two identification tests for gas each. So they would ask like the produced gas, how you identify? You would say if hydrogen is coming, you know from the theory. If hydrogen comes, you can say just put a the lighted splint. That lighted splint will be make scoopy pop sound. If that's so, that gas will be hydrogen. If the particular lighted splint, when you dip in here, glowing splint, when you dip in there, you can see that glowing splint is three lights. So therefore, the produced gas will be oxygen gas. Apart from these test guys, some gases you can identify from their colors because they have very oven colors, distinguished colors, such as the bromine gas is a brown color gas. Chlorine gas is kind of a yellow green, pale green color gas, but I2 gas is a pale brown color gas. Okay, so the fluorine in the note is fluorine mentioned, but that's no needed by guys here. Just take the color of gases here. Just remember Br2 gas, brown. Cl2 gas is yellow green, just say green color. Is enough. And the I2 gas, that is purple color. So these three colors, please just remember, very important. Sometimes they would ask from you the color of the gas produced. So when after electrolysis is done, these are some observation you would see. Okay, guys? Okay, right, just take the, like, do you want to take this note? Because we have done this stuff, the testing, the chemical test part earlier lesson, right? So this one we can copy later, isn't it, guys? We'll copy this part is later. So I will mention here this thing you need to copy later. And the reactivity series also you have to copy later. I'll send a screenshot. So please copy them later into your book rather than wasting time here. Right, okay. So we have done the theory. So we'll apply this particular scenario into several examples. Okay, guys, are you ready?
Okay,
Yes, sir.
Right, okay. We'll apply this into some examples. So we have today 14 people, 13 people. Our class supposed to have 19 people. Yeah, we'll see next time they all will come, right? And I would like to all people is speaking here. I'm so appreciate it, right? We'll see first example. The example is given above. The very first example we started. Think about, we have sodium chloride aqueous, example number 1. Sodium chloride aqueous. So first of all, my dears, we have to write the equation that makes ions. So sodium chloride aqueous will make Na plus aqueous as well as Cl minus aqueous. And we can't forget our H2O thing. H2O thing is very important. That gives you H plus aqueous as well as OH minus aqueous. So here we have competitors. So we'll see which one comes first. Guys, to the anode. Anode reaction. Anode is a positive charge one. All the negative ions are coming. Guys, to the anode concerning, here Cl minus, OH minus, both are coming. They all will say, sir, please take us, please take me, like that way. So which ion you are going to select? Cl minus or OH minus ion? Tell me. Guys, when you're selecting anions, we have to check whether my solution contain halides or not. Yes, this time we have a halide, which is Cl minus. So therefore, Cl minus first react. We are giving the priority for the Cl minus. So the anode reaction will be Cl minus becomes Cl2 gas, losing 2 electrons. Here aqueous and 2. So this is the anode reaction. Okay, guys, right. So anode is over. Finish. We'll go to the cathode reaction now. Cathode reaction concerning all the positive ions will come. Na plus and H plus will come. Okay, which ion we are going to select? Both ions are coming. Take me like that way. So which ion you are going to select, guys? H plus or Na plus? We have the priority.
So H plus.
H plus, because in the reactivity series says Na is above hydrogen, is a higher reactive metal. So those won't react here. Those, nothing will happen to them. So H plus will be reduce the equation I have mentioned here. H plus gain into electrons and become hydrogen gas. So easy, guys. See, it's nothing, just so easy. If you know the criteria, that's totally enough. That's enough. Right. After this, just tell me what are the ions are leaving here. You can see Cl minus is leaving, right? Because that's here oxidized. And H plus is reduced, that also leaving from the solution. So at the eventually what you have